Hello students, this is a video on section 13.5 which is about factoring binomials. So keep in mind that when they say binomials, just the same way trinomials have 3 terms, binomials have 2 terms. So for binomials, because they have 2 terms, we have to factor them a different way. And it turns out that there's only really 3 formulas that work for binomials. So to factor a binomial, you have to use one of the 3 following formulas. There's only 3 of them. So you've got the difference of squares, you got the difference of cubes, and the sum of cubes. Okay? So the difference of squares, the difference of cubes, and the sum of cubes. So let's go through these. The most common one is the difference of squares. People use that one all the time. For that one, if you have something squared minus something else squared, x squared minus y squared, you get x minus y times x plus y. This one is the most common and the most important. Now the other 2 formulas, instead of being squares, remember squares are the second power, the other ones are cubes. So cubes are actually the third power. So you got the difference of cubes, which is x cubed minus y cubed. That factors as x minus y times x squared plus xy plus y squared. And then you got the sum of cubes, x cubed plus y cubed. That one factors as x plus y times x squared minus xy plus y squared. Now again, difference of squares is the one that you're going to be using the most, and it's actually the easiest one as well, which is good. Difference of cubes and sum of cubes also shows up on your homework. Those can be a little bit more challenging because there's so much going on. Just make sure you copy the formula down correctly and you plug everything in to the correct place, because it's easy to mess up number 2 and number 3. Okay, and notice if you're looking at the difference of cubes and the sum of cubes, the only real changes in these formulas is where pluses and minuses go. So if you look at the difference of cubes, you'll notice difference means subtract. So it's x cubed minus y cubed. And for this one, there's an x minus y right there. And then there's a plus right here. So with the sum of cubes, it's almost exactly the same formula. The only change is you switch that plus and that minus. Okay, so these just switch. For this one, as you can see, the rest of the formula is the same. The only change is for the difference of cubes, you have a minus first and a plus second. For the sum of cubes, you have a plus first and a minus second. Okay, but other than that, the formulas are identical. So the rest of it is still x, y, x squared, xy plus y squared. All that changes are those. So that's good to know. And you don't have to memorize it for the test, obviously, because it's open book, open notes. But it is important to know the difference between the formulas. Well, so to speak, the change between the formulas. Okay, and you might be wondering, well, how come there's no sum of squares? So there's a difference of squares, which means you subtract squares. There's a difference of cubes, which means you subtract cubes. Sum of cubes, which means you add cubes. But there's actually no sum of squares. Okay, so notice the sum of squares, x squared plus y squared, is actually prime. It's not factorable, which means if you have x squared plus y squared, you can't factor it. Unless you have, say, a GCF that you can factor out, but that would be like the only thing you could possibly do. So usually, if you just have the sum of squares, if they're added together and they're squares, then the answer is going to be prime. Okay? So let's see some examples. So for our examples, we're going to go ahead and follow the instructions. And the instructions say, factor each binomial completely. Factor each binomial completely. Okay, and for problem number 1, we're going to do an easy one. This one is x squared minus 36. So for x squared minus 36, you notice that we have a square here, which means we're going to want to use the difference of squares. So we're going to want to use the first formula here because we have something squared, and we need to write it as something squared minus something else squared to use this formula. Okay, so all we have to do is, instead of writing 36, we need to write the number that when you square it, you get 36. Well, everyone knows that 6 squared is 36, because 6 times 6 is 36. So we can rewrite this as x squared minus 6 squared. Okay, and here this is the difference of squares. Difference of squares. So remember, it factors as the first thing minus the second thing times the first thing plus the second thing. So that's going to be x minus 6 times x plus 6. And that's actually all there is to it. That's the whole problem. So that's a relatively easy problem. You basically just plug into the formula. But of course they do get more difficult. But that's a nice easy one. Okay, so for number 2, let's take a look at 36x squared minus 1. 36x squared minus 1. So once again, when you see a square there, that means you want to use the difference of squares. But the tricky part here is you have to write the first term as something squared and the second term as something squared. And this one is not really written the proper way yet. So we need to write it as something squared, I'll put parentheses, minus something else squared. Well, let's start with the first term. Let's start with the 36. What squared gives you 36? Well, we just said 6 squared is 36. So here we have to write a 6. Okay, because 6 times 6 is 36. And then what squared gives me x squared? Well, x. Right, so we write a 6x here. Now notice I put parentheses around this. Why did I put parentheses around the first term? Well, it actually has more than one factor. It actually has the 36 and the x squared. So because it has 2 factors there, that's why I had to put parentheses around it, so that I had the 6 times x. And the square actually refers to this whole thing. Okay? And then the other question is, what do I write here? Well, what squared gives me 1? Well, 1 times 1 is 1, so 1 squared gives me 1. So here we're going to write minus 1 squared. And remember, the reason that works is the square doesn't actually apply to this minus, right? The square only applies to the 1. So 1 squared is 1, and then there's a minus out front, so that gives you negative 1. Okay, so that problem's harder, but we just did the hard part. The hard part is rewriting it as something squared minus something else squared. But now that we have it written in that form, we can go ahead and use the difference of squares. Okay, so for the difference of squares, you got the first thing minus the second thing times the first thing plus the second thing. Okay, that's our difference of squares. All right, and that's actually the whole problem. So that's our answer. And there's all kinds of tricks that you have to use on the different problems. So let's take a look at problem number 3. Problem number 3 is going to be more challenging. So number 3 is 144 x squared minus 169 y squared. 144x squared minus 169y squared. So once again, we see that we have squares here, so we're still going to be using the difference of squares. However, here, to use the difference of squares, once again, we have to rewrite it as the first thing squared minus the second thing squared. And because both of these have two factors, I'm actually going to put parentheses around both of these terms. Okay, and we want to have something squared minus something else squared. And then we really just need to fill in the blanks here. So first of all, what squared gives me 144? Well, hopefully you remember from your times tables, 12 times 12 is 144. So 12 squared gives you 144. And then of course we also need an x here, because x squared gives us this x squared up here. So we're actually going to have a 12x. And then we do the same thing over here. However, you might not know, well, what squared gives you 169? Most people don't know their times tables past 144. So what you can do is you could just use a calculator. If 12 squared is 144, you can start trying bigger numbers until you get 169. Or even easier, you just take the square root of 169. So if I open up my calculator, and then I do the square root of 169, that's actually 13. So if the square root of 169 is 13, that means 13 squared is 169. So we have minus 13y quantity squared. Alright, so now we've written it as the first thing squared minus the second thing squared. So now we can go ahead and use the difference of squares. So it's going to be the first thing minus the second thing. So that's going to be 12x minus 13y times the first thing plus the second thing. So that's going to be 12x plus 13y. Okay? First thing minus the second thing times the first thing plus the second thing. So there we go. That's our answer. Alright. Okay, so there's a few more tricks with the difference of squares that I wanted to show you. Okay, so for problem number 4, we actually have x squared, y squared, minus 1. So this one can be a little bit confusing for some people, which is why I'm covering it, so you know. The thing is here is you got the x squared times the y squared. So you might not be sure how to write that as something squared. So what you have to do is you put parentheses around it because it has more than one factor. You write the square outside of the parentheses, and then you just figure out what to write in here. Okay? So what do we write in here? Well, what squared gives me x squared? X. So I write an x there. And then what squared gives me y squared? Y. So we write a y here. So we're actually going to have xy inside of the parentheses, and then we have the square on the outside. Because that square actually distributes to each of those, and that gives you this. And then of course for the second term, we need to write that as minus something squared, but as we already said in an earlier problem, 1 squared is 1. So here we're going to write this as minus 1 squared. And I do not recommend that you try to do these in your head, because most people when they try to do these in their head, they mess them up. So it's better to just write it out like I'm doing here, because they don't even take that long. Okay, but now we've got the difference of squares, so we can go ahead and rewrite it as the first thing minus the second thing times the first thing plus the second thing. So that's going to be xy minus 1 times xy plus 1. And that's our answer. Okay? And believe it or not, there's still a couple more tricks when it comes to dealing with the difference of squares. So for problem number 5, we actually have a fraction. So for this one, we have x squared minus 1 over 64. X squared minus 1 over 64. So what's tricky about this one is just the fraction. But we can see that we have something squared. So we're going to want to rewrite this as something squared minus something else squared. Well, the first thing only has one factor, so we just leave the first thing as x squared. But for the second thing, we need to think about, with parentheses, what squared gives me 1 over 64? Well, in the numerator, we know we have 1, because 1 squared is 1. So that gives us our numerator. And then in our denominator, we have to think, well, what squared gives me 64? Well, from your times tables, you should know that 8 times 8 is 64. So that means we have to write an 8 in the denominator. Okay, so you should actually have x squared minus the quantity 1/8 quantity squared. But now that we've rewritten it as something squared minus something else squared, we can go ahead and write our answer. So remember, it's the first thing minus the second thing. So x minus 1/8 times the first thing plus the second thing. So that's times x plus 1/8. And I know it looks strange having it factored where we have fractions, but that's actually how they want you to write your answer. So this is actually how they did the whole problem, and that's our answer. Okay, so now you should be good for that one on your homework. All right, so we're going to see a couple more examples of the difference of squares. Okay, so problem number 6. Problem number 6. For this one, we have negative 16 r squared plus 1. Now this problem is outright tricky. The reason it's tricky is, I know I said there's no such thing as the sum of squares, and there's only such a thing as the difference of squares. However, if these terms are opposite signs like this, we can actually still write this as the difference of squares. So the trick is, because these are opposite signs, they're not the same sign, we're going to factor out a minus first. Okay, so that's the trick here. Factor out a minus to change into the difference of squares. Because the problem is, the way it's written is you're adding instead of subtracting. But because this term has a minus, what we can do is we can factor out a minus from the whole thing, and then we're going to have a plus and then a minus there, and then we'll be able to write it as a difference of squares. Okay, so if I factor out that minus, that's going to switch the sign of each term. So the first term is going to become positive 16r squared, and the second term is going to become negative 1. All right, so that was the trick there. And then for the rest of the problem, this is similar to an earlier problem. So now we can go ahead and factor this, because for the difference of squares, remember, it has to be a positive thing minus a it has to be a positive thing and then a negative thing. So something positive squared minus something else squared. So we had to get it in that exact form in order to use the formula. Okay, but now we've got it in mostly in that form. So now we need to rewrite the 16r squared as something squared. So let's see. Well, what squared gives me 16? 4. And then r squared gives me r squared. So we have 4r quantity squared minus, well, what squared gives me 1? 1. So we have minus 1 squared. And then we still have our minus out front. Okay? So since we factored out that minus, now we were able to go ahead and write it as a positive thing squared minus something squared. So now it's the difference of squares. So this is the difference of squares. Okay, so it factors as the first thing minus the second thing times the first thing plus the second thing. Okay, 4r minus 1 times 4r plus 1. And then just don't forget, you still have a minus out front. So that's included in your answer. Okay, so our answer is negative of 4r minus 1 times 4r plus 1. Pretty cool, huh? Alright, so we're almost through with the difference of squares. I know that's a lot of problems, but I wanted to cover almost all the cases. So this last example of the difference of squares is probably the easiest one if you know what to do, but also the most confusing if you don't know what to do. So for this one, we have 36x squared plus 25. So here, this is not the difference of squares, this is the sum of squares. So you might think, oh, well, maybe it's just like the last problem. Maybe I can just go ahead and factor out a negative 1, and maybe that'll do it. But that's actually not going to work. So if I factor out a minus here, that's going to switch the sign of both terms. So we would have a negative 36x squared minus 25. So if I factor out a minus here, remember the first term actually has to be positive and the second term has to be negative. So the problem here is because the first term is negative, it's considered not the difference of squares. Okay? Which means it's the sum of squares. Now I know that sounds very confusing because we can see here that we're subtracting. But it's called the sum of squares because both terms are positive. So if you factor out a minus, both terms are negative. And so that's considered unfactorable. Okay? So it's not the difference of squares, it's the sum of squares because both terms started out positive. If you look at the last problem, the first term was negative and the second term was positive, so we were able to factor out a minus, and then we were able to get it in the correct form where it's a positive thing minus something else, so positive negative. But with this one's actually the sum of squares because both terms are positive, so we can't rewrite it as a positive and then a negative. So this is not the difference of squares, this is the sum of squares, which means it's unfactorable. So our answer is prime. Remember, the word prime just means you can't factor it. So that means unfactorable. So this is not something we can factor. Okay? So I think that covers pretty much your whole homework with regards to the difference of squares. Oh, I'm sorry, I take that back. Well, there's a couple more. I really got carried away when I was making your homework. So let me show you a couple more cases for the difference of squares. Okay, so number 8. 256 m to the fourth minus 625. 256 m to the fourth minus 625. Okay, so for this problem, once again, you do want to write it as a difference of squares. Well, we got the first term is positive and the second term is negative, so we're good there. So we want to write it as something squared minus something else squared. The problem here is we have big numbers. So what I recommend you do is you use a calculator. So you just use the square root button on your calculator, or if you don't have a real calculator, just use the one on the computer like I do. So what's the square root of 256? Well, I just type in 256 and then I press the square root button. That's 16. So what does that mean? That means 16 squared is 256. So here, for the first term, I'm going to go ahead and write a 16. Okay, and then another tricky thing here is because we had m to the fourth, well, what squared gives me m to the fourth? Actually turns out that we need to write an m squared. Because m squared squared means you multiply the exponents, and 2 times 2 is 4. So 16m squared squared gives you 256m to the fourth. And then for the second term, once again we have a big number here, 625. So what we want to do is we want to do the square root of that big number. So what's the square root of 625? Well, I type in 625, and then I press my square root button, and that actually turns out to be 25. So that means 25 squared is 625. Okay, so we have 16m squared squared minus 25 squared. So now we've written it as the difference of squares, so now we can go ahead and factor. So this is going to factor as the first thing minus the second thing. So that's going to be 16m squared minus 25 times the first thing plus the second thing. So that's going to be times 16m squared plus 25. Okay? And then we're almost good here. But you might think you were done, right? But you actually can factor this more. So this is a pretty tricky problem. So this part over here on the right is the sum of squares. So that is not factorable. That's unfactorable. That's prime. But the part on the left, here in blue, is actually still the difference of squares. So it turns out that you can factor it again. So this is a tricky problem. So to factor the difference of squares, what you have to do is you have to rewrite it as something squared minus something else squared. So what squared is 16? Well, we all know 4 times 4 is 16. So here we're going to have 4m squared minus, well, what squared is 25? 5 times 5 is 25, so that's going to be minus 5 squared. So we're going to have 4m squared minus 5 squared. But the 16m squared plus 25, because that's the sum of squares, we aren't going to be able to factor that. So because this part is prime, we just leave it that way. Okay? And then to factor this first factor, we write it as the first thing plus the second thing times the first thing minus the second thing, or vice versa. Sorry, I said it in the wrong order. But remember, when you're multiplying, the order doesn't matter. So I'm going to rewrite this as the first thing minus the second thing, so 4m minus 5, times the first thing plus the second thing. So that's 4m plus 5. Okay? And then we still have a 16m squared plus 25. Okay? So we have 4m minus 5 times 4m plus 5 times 16m squared plus 25. And that's our final answer. We can't factor these because they can't be written as something squared. And then we can't factor this one because it's a sum of squares. So we're finally done factoring it. And that's almost as tough as your homework gets. But there's actually one more tough problem for the difference of squares. So for problem number 9, we're going to take a look at x to the 12th minus y to the 14th. x to the 12th minus y to the 14th. Okay, so for this one, the tricky thing is just writing it as something squared minus something else squared. So first of all, we write our parentheses, and we want to have something squared minus something else squared. Well, what squared gives me x to the 12th? Well, like I said, you're multiplying these exponents here when you're raising a power to another power. So we know we're going to need an x. And then we need to ask ourselves, this number times 2 gives me 12. So what times 2 gives you 12? Well, 6, right? 6 times 2 is 12. So this is actually going to be x to the 6th. And then we do the same thing for y. So we have to have a y here. And then this number times 2 has to give me 14. So what number times 2 is 14? 7, right? Just from your times tables. So we got y to the 7 times 2 is y to the 14. So you should have x to the 6th squared minus y to the 7th squared. And that was the tricky part, is just rewriting it. But now that we have it rewritten, we can write it as the first thing minus the second thing times the first thing plus the second thing. So this is going to be x to the 6th minus y to the 7th times x to the 6th plus y to the 7th. Okay? And you might be wondering, well, are we done with this? We actually are. So the reason we can't factor this one anymore is because this factor here is not an even exponent. If this was an even exponent, like if it were 8, then we could keep factoring this because this would be the difference of squares. But because this exponent is odd, this is not a difference of squares. So you can't factor this one, and you can't factor that one either. You can't write this one as the sum of cubes or the difference of cubes, because again, 7 is not it's not a power of 3, so we can't rewrite that as the sum or difference of cubes. So this is actually our answer. So our answer is actually x to the 6th minus y to the 7th times x to the 6th plus y to the 7th. Okay. So I put a lot of those difference of square problems. I might have gotten a little bit overzealous there, but it's good to see all those cases. And then for the rest of your homework, we're going to be doing the sum and difference of cubes. Okay. So let's see a problem where we do the sum of cubes and a problem where we do the difference of cubes. Okay, so for number 10, we want to factor m cubed plus 64n cubed. Now because we have cubes here, we're going to be using one of those two formulas that I taught you for the sum or difference of cubes. And because we're adding here, that's actually going to be the sum of cubes. Okay? Because sum means add. Okay, so sum of cubes. So what it is it's not that hard if you write down the formula right and plug everything in. Way up here. Let me go way up here on the board. So the formula for sum of cubes, you basically just want to copy it down correctly, and then you plug everything in. You simplify it a little bit. But the tricky part is you just have to copy down the formula correctly. So it's x plus y times x squared minus xy plus y squared. Okay, so it's going to be, for the sum of cubes, the way it factors is it's x plus y times x squared minus xy plus y squared. Right, that's the formula for the sum of cubes. And then you want to label stuff. So here we can see that x is the same as m. So here x equals m. And then what's y going to be? Well, for y, we're actually going to have 64, and we're going to have to take the cube root of that. So how do you take the cube root of 64? Well, this calculator here doesn't have a cube root button. So what I do is I do 64, and then I press the exponent button. And then I go ahead and type in parentheses, and then I do 1/3. So if I do 1/3, that actually should give me the same as the cube root. And I know we haven't done a lot of radicals, but that's how you do the cube root on a calculator. If you don't have a cube root button, you just do the number to a fraction power, and then the denominator of your fraction is the same as the cube root. So what this means is 4 cubed gives me 64. Okay? So instead of writing 64n cubed, I can actually write it as 4n quantity cubed. Okay? So x is going to equal m, and y is going to equal 4n. So this one right here is 4n cubed, 4n quantity cubed. So that means our y is actually going to equal 4n. But if you label them like this, x equals m, y equals 4n, because 64n cubed is 4n cubed, then you can just plug everything into the formula. So plugging into this formula down here, we've got x plus y, so that's going to be m plus 4n, times x squared, so that's going to be m squared, minus xy, so that's going to be minus m times 4n, plus y squared. So that's going to be plus 4n quantity squared. And notice I put parentheses around the 4n. That's important when you're plugging it in, because it's actually going to be the 4n quantity squared with parentheses around it. All right, and then we just need to simplify this a little bit. So we can't simplify the m plus 4n, so we just leave it that way. And then over here we have m squared minus 4mn. Okay, and then for the 4n quantity squared, 4 squared is 16, because 4 times 4 is 16. And then we've got our n squared. Okay, so there basically all I did was I distributed this exponent, and we got 4 squared is 16, and then n squared is n squared. Then over here, I just wrote the 4 first, and then I wrote mn in alphabetic order just to make it easier to read. Okay, so that's our answer. M plus 4n times a quantity m squared minus 4mn plus 16n squared. Okay, so hopefully that's not too bad. So that was an example of the sum of cubes. And then I wanted to give you an example of the difference of cubes. And I wanted to do a harder one just so that you can see the tricks. So for problem number 11, we want to factor 16x cubed minus 2y cubed. 16x cubed minus 2y cubed. Now, as you can see, we've got cubes, and we're subtracting. So that means we're going to be using the difference of cubes. Difference of cubes. Because difference means subtract. Okay? But the tricky part here is noticing that there's actually a GCF that you can factor out first. Okay, so we're going to factor out the GCF first. Now, why do we want to factor out the GCF first? Well, if we don't do that, it might be pretty hard to actually factor this. But if you factor out the GCF first, it's not so bad. So what's the GCF here? Well, what we have in common is, well, 2 goes into 2 and 2 goes into 16, so the GCF is going to be 2. So we're actually going to factor out a 2 first. And if we factor out a 2, we're going to be left with 8x cubed minus y cubed. Okay, so all I did there was I factored out the GCF, which is 2, and I was left with, well, 2 times 8 is 16, so we're left with an 8x cubed there. And then we have a negative y cubed here, because 2 times negative y cubed gives you negative 2y cubed. So the trick here was to factor out the GCF first, and now we can actually use the difference of cubes, because you always have to factor out the GCF before you do anything else. And this is a problem where it has a GCF. On all the other problems, on most of the other problems we've dealt with, there was no GCF that we needed to factor out. So if there's no GCF to factor out, you don't have to worry about that step. But on this one, there's a common factor of 2, so we have to do that at the beginning. We have to factor it out. Okay? So what we do next is, now we can go ahead and apply the difference of cubes. But what you want to do is you want to take the cube root of 8 here, so that I can write this as something cubed. Okay, so taking the cube root of 8, how do I do that? Well, I press 8, and then I press my exponent button, which is right here. And then I'm going to do parentheses, and then I'm going to do a 1/3 power. So raising it to the 1/3 power. And then I press enter, and that gives me 2. So that's just saying the cube root of 8 is 2, which means that 2 cubed is 8. Okay, so what we have here is we actually have a 2x quantity cubed minus y cubed. Okay, and then we also have a 2 out front. Now, if we write down our formula, it can get kind of confusing because the x and the y are different here. But if we look at the formula for difference of cubes, the formula is x cubed minus y cubed equals x minus y times x squared minus x, plus xy plus y squared. I almost forgot the formula. It's written up there. It's easy to forget it. But anyway, this is our formula. But here our x is actually going to have to be 2x, which makes it a little bit confusing. So here our x is 2x, but our y is still y. So plugging in here, instead of x minus y, we're actually going to have 2x minus y. So we have 2x minus y times, well, instead of x squared, we're going to have 2x squared plus xy. Well, instead of that, we're going to have plus 2x times y. And then because y is the same as y, we're still going to have a plus y squared. Okay, so there's the difference of cubes. We plugged everything in, and then we have to simplify this just a little bit. Okay, so what do we have here? Well, we've got 2x minus y times, well, what's 2x squared? Well, 2 squared is 4, because 2 times 2 is 4. And x squared is x squared. So we get 4x squared plus 2xy plus y squared. So really the only thing that we could simplify here was this right here, 2x quantity squared. And 2 squared is 4 and x squared is x squared. So this is our answer. 2x minus y times 4x squared plus 2xy plus y squared. So that's an example of one of the harder problems with the difference of cubes. Now I forgot something. what did I forget? I actually forgot the GCF. So remember, I factored out that 2 way back here, but I forgot that. So that 2 is still out front. So I forgot to write that in my answer. It's easy to do, but you don't want to do that. So we still have a 2 out front here. And so our answer still has a 2 out front. And that's one good reason why you want to actually check your work. Even if you don't bother to multiply it all out and check it that way, you want to check back here and make sure you did every step right. Okay? But now that we got the 2 out front and we factored this, we're good. So that's the difference of cubes.